Okay, so I have good news. The good news is we're all done with derivatives. That's the good news. No more derivatives.
No.
We're done with derivatives for this semester. Yes? Derivatives was the answer to everything.
It says derivatives right there.
No, it says anti-derivatives.
But derivatives is there.
Does that mean we're finding where the derivatives came from now?
That means we're going to find where the derivatives came from. All right, so we say capital F of x is an antiderivative of little f of x if the derivative of capital F gives me little f. So it's kind of like we're going to be playing Jeopardy today. In the past, I would give you the function and I would say, tell me the derivative. Today, I'm going to give you the function and I'm going to ask you, give me the function that when I take its derivative, I get this answer. Which sounds hard. So for example, I might give you f of x is 2x. The derivative of what would give me an answer of 2x?
X squared plus c.
X squared is a correct answer. But it's not the only answer.
Plus c.
Where what's c? A constant. It could be any number, couldn't it be? X squared is a correct answer. X squared plus 5 is also a correct answer, isn't it? Because if I take the derivative of x squared plus 5, what do I get? 2x. If I had x squared minus 1,000, the derivative of x squared minus 1,000 would be 2x. So how many correct answers are there? There are an infinite number of correct answers. So what we do is we tend to say the answer is f of x equals x squared plus c. Where plus c means you can tag on any constant you want on the end. Just because I write plus c, does it mean it has to be a positive number? No. Well, c could be the number negative 10. So it could be x squared plus negative 10, which would be x squared minus 10. So there's not just one correct answer, there are an infinite number of correct answers. All right, how about g of x equals x squared? What is the general antiderivative of x squared? The derivative of what would give me an answer of x squared? 1/3 x cubed plus c. Because if I take the derivative of 1/3 x cubed, I'm going to bring that 3 down, aren't I? And the 3 and the 1/3 are going to cancel out. So the antiderivative of x squared is 1/3 x cubed plus c. I agree completely. How about if h of x is x to the 4th? Then the antiderivative of x to the 4th is 1/5 x to the 5th plus c. Absolutely, you will always put plus c at the end. Absolutely. The new answer to everything is plus c. Correct.
So we'll always get it right if we put plus c.
Is
that what you're saying?
No, I'm not saying you will always get it right. For example, if you just wrote x to the 5th plus c, that still wouldn't be right. Plus c would be good, but the x to the 5th there would be wrong.
So we get half credit.
So you'd get some credit. Okay, well there seems to be kind of a pattern here. The antiderivative of x squared was 1/3 x cubed. The antiderivative of x to the 4th was 1/5 x to the 5th. What seems to kind of be the pattern here? Okay, so if I start with an x to the 4th, I add 1 to my power, and then divide by the new power. Right, and that makes sense, because you remember if we had f of x was x to a power, what was the rule for derivatives of x to a power? You bring the power down, you subtract 1 from the power. Antiderivatives are the opposite. So if f of x is x to the p, then the antiderivative, what's the opposite of bring the power down and add 1 to the power? I'm sorry, bring the power down and subtract 1 from the power. Add 1 to the power and then divide by the new power. Now this rule works just wonderfully as long as p is not the number -1. How come this rule would not work so wonderfully if p were the number -1?
Can't divide by 0.
You would be dividing by 0. Can you divide by 0? No, you may not divide by 0. All right, well, it turns out there's a nice fancy symbol we use for antiderivative. And the nice fancy symbol we use would look like this. The fancy symbol for antiderivative is that. It looks like an S. It's actually called an integral sign. That's a symbol for integral, whatever integral means.
And keep in mind that an integral is not an antiderivative.
An integral and an antiderivative are not exactly the same. That is correct. They are very, very, very similar, however.
So for these, do we just write the capital F in, or do you want to write?
Well, what you're going to see is you're going to see this symbol. So I might write what's the antiderivative of x cubed? Now notice this antiderivative symbol is kind of strange because you've got this thing at the beginning and you've also got this thing at the end.
So isn't it just X cubed?
Nope. So what's the antiderivative of x cubed? You add 1 to the power, that's x to the 4th. You divide by the new power, and then plus c. Always put a plus c on the end. Wait, do you have to mess with c? We'll mess with c here in just a few minutes.
So why did you put the X to the third there instead of F of X to the third?
Well, x to the 3rd would be my little f of x here.
So with those symbols, it's just
So-
implied.
So in this symbol, f of x would be x cubed, and capital F of x would be 1/4 x to the 4th plus c.
Oh,
So these two lines say exactly the same thing,
yeah.
just I'm using the symbols for antiderivative.
No, you
That was okay.
Okay.
So the d of x is just the derivative with respect to x. Like there's no having.
The d of x is something very important, but I cannot explain that to you today. We will get to that sometime next week. Why do we put the little dx there? For now, what you need to know is every time you write that big fancy S thing, you better write a dx at the end. What if you don't?
Failed test and quiz and everything.
The teacher will take points off. That's correct.
I'm sorry, but that's going to bother me. Why can't you explain it? Is that-
Because it has something to do with integrals. And we haven't got to integrals yet. All we've gotten to is antiderivatives.
Sounds like we should have done integrals first.
But you know what I
It's
do?
like
Antiderivatives too.
you have to know how to get the antiderivative because the antiderivative is the basis of an
Right.
integral.
In order to be able to do integrals, you need to know how to find
We
antiderivatives.
do it all in one day.
Exactly, that's what I would
Well, we don't have time to do it all in one day. Oh, there's so much to do before we get there. You'll be amazed. All right. Now, what if we have an antiderivative like so, but we've got something more than just x to a power? What do you think you do if you have the antiderivative of x squared plus 4x minus 5? No, it's not going to be plus 4. Okay. What if, just remember back to our rules for derivatives, what if I gave you f of x as x squared plus 4x minus 5 and I asked you to find the derivative? What would you do?
Drop it. Or the -5 would just be dropped.
Okay, the derivative of negative 5 would be 0. The derivative of 4x would be, and the derivative of x squared would be 2x. So to find the derivative, as long as you're adding and subtracting, you just find the derivative of each piece individually, correct? F prime of x would be 2x plus 4 minus 0. Same thing works with antiderivatives. As long as you're adding and subtracting, to find the antiderivative of something like this, you simply find the antiderivative of each piece. So what's the antiderivative of x squared? 1/3 x cubed. Plus 2x squared. Excellent. Why is it 2x squared? the 4 stays, just like it does with derivatives, the 4 stays with antiderivatives.
You don't actually add the plus C.
We'll put plus C at the end. Okay? So the antiderivative of 4x, you told me, was 2x squared, and this should have been x cubed back here, shouldn't it? Minus, what's the antiderivative of 5? 5x. And then plus C goes on the end. So it's kind of the exact same rule we had for derivatives. When we were finding derivatives, if we had a polynomial like that, we simply found the derivative of each piece. Same thing works for antiderivatives. If you have a polynomial, you simply find the antiderivative of each piece individually. Oh, it gets a lot harder.
That's the real question.
Oh, yes.
For example, I'll start making it harder just for fun.
Can we do the double where you have to add stuff to C and then start squaring C?
I don't like that idea.
Not today.
I don't like that one. I don't like
What if I ask you to find the antiderivative of 2x minus 5 times 3x plus 8? Do you FOIL first? You must FOIL first. That makes it a lot easier. We do not have a product rule for antiderivatives. We also do not have a quotient rule for antiderivatives. Those are derivative rules. Those are not antiderivative rules. So if you have something like this, your only option is to FOIL it out. So that doesn't make it terribly hard, does it? You FOIL it out. You're going to have antiderivative of 6x squared. Let's see, what are you going to have? You're going to have 16x minus 15x. That's going to be plus x minus 40. There is no product rule for integrals. There will never be a product rule for antiderivatives. Never, never, never. We will never have one. Why not? Because there isn't one. It simply doesn't work. In this class, we will learn something called integration by substitution. Integration by substitution is the reverse of the chain rule. Whatever that is, however you reverse the chain rule. And then when you take Calc 2, you will learn all sorts of different ways to find antiderivatives. But there's no set one way that works. In reality, derivatives were easy. If you have the product rule, the quotient rule, the chain rule, you can find the derivative of almost everything. With antiderivatives, when you take Calc 2, you will learn integration by substitution, you'll learn integration by parts, integration by partial fractions, integration by trig substitutions, integration by special substitutions, and I'm missing one.
This is why you need to do
The mystery one. Whatever it is, I forget.
Is it one that's like seldom used?
No, it's used. And then, even with all those techniques,
there's still some you can't.
there are still lots and lots and lots of functions that you cannot find the antiderivative of using those rules. And you have to try, there are even other techniques. And then, no, I will never give you one that you cannot find the antiderivative of. That would be fun. All right, anyway, let's finish this problem. So what's the antiderivative of 6x squared? 2x cubed. Plus, what's the antiderivative of x? 1/2 x squared. Minus, what's the antiderivative of 40? 40x plus c. Very good. No, I didn't say it was a hard one. I said it was harder. Okay. How about the antiderivative of 5x minus 3 divided by square root of x? How would you find the antiderivative of 5x minus 3 over the square root of x? Absolutely. We do not have a quotient rule. So what you have to do is get rid of the division. And then you have to do the distributive property because we do not have a product rule either. We do not have a quotient rule. We do not have a product rule. So we need to get rid of the quotient first. We get rid of the quotient by writing it as a negative exponent. Then we get rid of the product by distributing. So that's the integral of 5x to the 1/2 minus 3x to the minus 1/2 dx. What's the antiderivative of 5x to the 1/2? Okay, the 5 is going to stay, right? You're going to add 1 to your power. What's 1? So that's going to be x to the 3/2. And then you have to divide by 3/2. How do you divide by 3/2? Flip and multiply by 2/3. All right, so that's where these get a little bit harder when you start having to deal with fractions. Minus 3 x to the what power? What's negative 1/2 plus 1? 1/2. Divide by 1/2. Dividing by 1/2 is the same as multiply by 2. Plus c. Very good. Don't forget the plus c. There's a plus c on the end. Questions on that?
Does it still get harder than this?
Does it still get harder? Boy, you're a glutton for punishment today.
Like on a test and stuff, will it still get harder than that?
I don't know. Let's see. What's the antiderivative of sine x? Cosine x. Nope. The derivative of sine is cosine. What's the antiderivative of sine? Negative cosine. Why negative cosine? Because the derivative of cosine x is negative sine x. So if I want to get a positive sign, I've got to have a negative sign to begin with. The derivative of cosine would be negative sine, so I would have negative and a negative to get my positive back.
What kind of word problems are we going to have with these?
Oh, we'll get to that. We're not done yet. We'll get to that. What's the antiderivative of cosine x? Sine x, because the derivative of sine is cosine. Plus c. What's the antiderivative of tangent x? No, not secant squared. Not secant.
Is it like secant over tangent or something?
No. We don't know.
I thought you said you were going to do that.
I lied to you. We don't know. Because we know the derivative of tangent is what? Secant squared. The derivative of tangent is secant
We
squared.
don't have one that just specifically is tangent.
We do not have one where I take the derivative and I just get specifically tangent, do we?
We have one where tangent's in it, but not.
So we have one that has tangent in it. So for example, I know the antiderivative of secant x tangent x. That would be secant x, because the derivative of secant is secant tangent. I know the antiderivative of secant squared. What's the antiderivative of secant squared? That one's tangent, because the derivative of tangent gives secant squared. Joe.
The tangent dx one, you forgot to add plus c after
Very good. So I always thought this was kind of weird. We know the antiderivative of secant squared is tangent. What's the antiderivative of secant? We don't know. We don't have a rule that says the derivative of something gives me secant. So the antiderivative of secant is?
Shouldn't it just be the square root of tangent?
Nope.
Does anyone know?
Oh, I know, but we don't know. There's a difference. When you take Calc 2, you will learn that the antiderivative of tangent is natural log of secant.
Oh, okay.
Yeah.
Of course. Yeah, I'm surprised you guys didn't guess that.
Are you getting us a bonus?
Wait, I have a guess. The secant one, is that like natural log of tangent?
No, but you're not far off. The antiderivative of secant,
Is that what you see?
I believe, becomes the natural log of the absolute value of secant x plus tangent x. Let's see.
Yeah,
That
it's,
totally makes sense.
It's so clear. It's so clear once you see the answer, right?
it clicks, you know?
All right. So when you take Calc 2, you will learn those rules. But for now, you have some weird rules that you should know. You should know the antiderivative of secant times tangent, even though you don't know the antiderivative of secant and you don't know the antiderivative of tangent.
It's just doing what we learned in derivatives backwards.
It's derivatives backward. That's exactly what it is. Correct. Okay, now people said we wanted to mess with the plus c. Well, we can mess with the plus c too. So I might ask you this. Solve the differential equation. This is all new stuff. F prime of x equals x squared plus sine x. F at, give me a number.
0.
0 equals
2.
2. Okay, so what does it mean to solve the differential equation? First off, what is a differential equation?
It's
An integer.
A differential equation is an equation that has a derivative in it. That's a differential equation. What does it mean to solve the differential equation? You want to find the original function. So I've given you the derivative. I want you to tell me the original functions. That's what it means to solve a differential equation. A year from next spring, you'll take a course called Differential Equations. There's a whole course on it.
Yeah, isn't it like Calc 3?
No, it's Calc 4, actually.
Yeah.
But it's usually not called Calc 4. It's usually called Differential Equations.
Is there a partial difference between?
There's also such a thing called partial differential equations. So the course you will take here is actually properly called ordinary differential equations. And then when you go to a four-year university, you might take a course called partial differential equations. Partial, it must be so much easier, right? You only got to do part of it. You don't do the whole thing. Anyway,
If simple is first, then partial's got to be more complicated.
f of x is, I find the antiderivative. What's the antiderivative of x squared? 1/3 x cubed. Minus cosine x plus c. Now, what this does, this is called an initial condition. What this does is this allows us to plug in a number for x, and we have a number for f of x, and it allows us to do what? Find the value of c. So I'm going to plug 2 in for f of x, and I'm going to plug 0 in for x. So I'm going to have 2 equals 1/3 times 0 cubed minus cosine 0 plus c. So 2 equals, well, what's 0 cubed? What's 1/3 times 0? Minus, what's the cosine of 0? 1 plus c. So c is 3. So our final answer would be f of x is 1/3 x cubed minus cosine x plus 3. That's not too bad at all, I agree.
No, I meant the third derivative, going backwards from the third derivative.
Oh, going backward from the third derivative? No, we won't do that today.
That's the one I was talking about. That's messing with C and D and E.
We will tomorrow, which is Monday, of course. Tomorrow's always the next day we have class. On Monday, we will talk about some word problems that we do with these antiderivatives, and we will be doing antiderivatives of second derivatives, which just means you do it twice, right? If you have a second derivative, you do the antiderivative once, that gives you the first derivative. You do the antiderivative again, that gives you the original function.